Hello, this is Math 2270 from the College of DuPage, summer of 2020, and we're going to conclude our discussion of. So here you're being asked to solve the initial value problem and find the interval of validity for the solution. You know what you should do. Let's see how you did. So we separate variables this way. We integrate both sides, getting this. And we put the constant here. This is a good time to figure out what the constant is, and so if we substitute x to be 1 and put y to be 3, we discover that c has to be minus 2. So we have an implicit solution that is y squared minus 4y is equal to this cubic polynomial in x. But we can solve this for y by moving this to the other side, and we see we have a quadratic in y. This is really a constant as far as y is concerned. So we use the quadratic formula to get that y is equal to this, and then it's equal to this when I do a little bit of simplification. But now we have plus or minus, so we have to figure out is it the plus or the minus. But we can use this initial condition to determine, does it have to be the plus or does it have to be the minus? And when we think about that, we determine, oh, it's not going to be so it has to be 2 plus 1 to be 3, not 2 minus 1, and so it has to be the plus, and so now we have the solution. And what is underneath the square root must be bigger than or equal to 0. We can find that there's actually only one real 0 to this that's near this point, and so the interval of validity is the one that has 1 in it. 1 is way over here, so it's going to go from that number all the way to infinite. Here's another problem. You're to solve the IVP and find the interval of validity of the solution. You know what to do. Let's see how you did. So we separate variables here and integrate both sides, getting this. Again, we put the constant here. This is a good time to figure out what the constant is. We use the initial condition to figure that out, and so c is going to be minus 3/2. So we substitute that in, and now we want to try to solve for y. So we do this, and again we get a plus or minus. But again, the initial condition gives us a clue because the solution has to be negative, so it has to be the minus sign like that. To find the interval of validity then, this has to be greater than 0. It can't be equal to 0 because it's in the denominator. So we solve this and find that x squared is less than 5 over 4. That means that the absolute value of x is less than the square root of 5 over 2, and that means that x is between these two values. That ends up being exactly where 0 is, so that is the interval of validity. Here's another one to solve the initial value problem and determine the interval of validity of the solution. You know what to do. Let's see how you did. We separate variables like this. We integrate both sides to get this expression. And we put the constant here, and we can use the initial condition to determine what the constant is, and we find the constant has to be minus 4. So that means we have this is the solution with that being a minus 4, but we solve explicitly for y by taking the natural logarithm of both sides. So y of x is equal to the ln of this expression. Now we need to find the interval of validity. That means that this has to be bigger than 0. We'll find out when it's 0. We use a quadratic formula and we find out that this expression is 0 here. So that means we have possible intervals of validity. And the one containing 5 is this one. Solve the initial value problem and find the interval of validity for this initial value problem. You know what to do. Let's see how you did. Separating variables, we get this. We integrate both sides and we get this. The absolute value, of course, does matter. At this point in time, it's good to figure out what c has to be. We substitute 1 in, and we realize that the natural logarithm of 1 is 0, so c is minus 1/2. So now we can solve for r, and we get r is equal to this. Now, we cannot have a 0 in the denominator, so we'll figure out what values we have to avoid, and we find out that we have to avoid plus or minus the square root of e. This gives rise to several possibilities for the interval of validity for this problem. And the interval of validity that contains 1 is this one. And so that is the interval of validity for the problem. Here we are solving the initial value problem. Note that you are not being asked to find the interval of validity. You'll see why in a bit. You know what to do. See how you did. Separating variables gives us this. We do have to realize that e to the y minus t is e to the y times e to the minus t in order to do that. Now we integrate both sides. Now we have integration by parts twice here, and actually I think twice here as well. So it's quite a bit of integration by parts, but we end up with this expression is equal to this expression plus c. We use our initial condition to figure out that c is 5 over 2. So we have this expression. Now this is not an easy problem to solve for y. In fact, it is quite formidable. But we look at the graph, and I look at the graph. The initial condition was 0, 0, and this is kind of a wild and crazy graph, but this is what we have for that. And so what the initial condition then is going to be that branch of this problem. And so whatever this value is, I don't know what it is without solving that expression, but this from this point to minus infinity would be the interval of validity. Okay, I told you I would tell you where we were and where we're going. We finished the integration review, and we've talked about separable equations. Next we'll talk about homogeneous equations. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of others. May God bless.